Welcome to our channel, Occupational Health and Safety and Environment. How to carry out a safety risk assessment. What is a hazard? What is a risk? How to carry out a risk assessment. How do you control the risk? Definition of a hazard. A hazard is any source, situation, or act with a potential for harm in terms of human injury or ill health, or a combination of these. Anything that can cause and harm. For a hazard to cause harm, a safety hazardous event must happen. The likelihood is the chance that the hazardous event will occur. Likelihood. To be eaten by Nile crocodile when you are visiting Africa is high, while to be attacked by a polar bear is almost impossible. What is effect, severity, consequence? The effect, severity, or consequences is the outcome of the safety event. The effect can be more or less severe. Based on the effect, severity, or consequence, the safety events are classified in the following classes: fatality, major or minor accident, incident, near miss, property damage. What is a risk? Combination of the likelihood of an occurrence of a hazardous event or exposure and the severity of injury or ill health that can be caused by the event or exposure. Risk equals likelihood times severity or consequence. Example of hazards and risks. Hazard, fall from the ladder. Effect, fracture or fatality. Risk, likelihood to get a fracture or to die by falling from the ladder, expressed in a number. In short, a fracture is not a hazard. It is the effect of falling from the height, normally higher than 1.82 meters. The hazard is the possible falling from the height. Other example of hazards and risks. Hazard, potential contact with a sharp iron rod in the construction site. Effect, to get wounded. Risk, expressed in a number. What is a risk assessment? A risk assessment is a careful examination of anything in your work environment that could cause injury or ill health. Why risk assessment? A risk assessment helps to protect you, your colleagues, your business. When we are performing a good risk assessment, we can not only identify hazards, but also make a prioritization so to work first on the most dangerous one and reduce the risk at an acceptable level. Risk assessment is also a legal requirement. Analyze and evaluate the impact of risks. Once you have identified the risks to your business, you need to assess the possible impact of those risks. You need to separate minor risks that may be acceptable from major risks that must be managed immediately. Analyzing the level of risk. To analyze risks, you need to work out the likelihood of its to happen, referring to its frequency or probability and the consequences it would have, or the impact of the risks you have identified. This is referred to as the level of risk and can be calculated using this formula. Level of risk equals consequence times likelihood. Level of risk is often described as low, medium, high, or very high. It should be analyzed in relation to what you are currently doing to control it. Keep in mind that control measures decrease the level of risk, but do not always eliminate it. A risk analysis can be documented in a matrix, such as this. Likelihood scale example. Level 4. Likelihood. Very likely. This happens more than once a year in this company. Level 3. Likelihood. Likely. This happens about once a year in this company. Level 2. Likelihood. Unlikely. This happens every 10 years or more in this company. Level 1. Likelihood. Very unlikely. This has only happened once in this industry. Consequences scale example of only 4 ratings. There are other with 5 level of rating that are more precise. Level 4. Consequence. Severe. The impact is likely to cause business to stop trading or significant financial losses felt. Level 3. Consequence. High. This has a major impact on your business with large financial loss. Level 2. Consequence: moderate. This has a moderate impact on your business with some financial loss. Level 1. Consequence: low. This has an insignificant impact on your business with minimal financial loss. Note: ratings vary for different types of businesses. The scales above use for different levels, however. You can use as many levels as you need. You will find examples in next slides. Also use descriptors that suit your purpose. For instance, you might measure consequences in terms of human health or environmental impacts, rather than dollar value. Evaluating risks. Establish the level of risk. You then need to create a rating table for evaluating the risk. Evaluating a risk means making a decision about its severity and ways to manage it. For example, you may decide the likelihood of a fire is unlikely, a score of 2, but the consequences are severe, a score of 4. Using the table sand formula above, a fire therefore has a risk rating of 8. This means 2 times 4 equals 8. Risk rating table example. When we have used a scale that is calibrated to 4 instead of 5, the risk rating between 12 and 16 is severe and needs immediate corrective action. Risk rating between 8 and 12 is high and needs corrective action within 1 month. Risk rating between 4 and 8 is moderate and needs corrective action within 3 months. Risk rating between 1 and 4 is low and does not currently require corrective action. The below risk matrix that is more precise with 5 level of rating is frequently used. This is the risk matrix with a scale of 5. It is obtained by multiplying the likelihood number with the number related to severity or consequence. Example: if likelihood is unlikely or a rating of 2, and when severity is major or a rating of 4, you get a number 8 in yellow. Thus, the risk ranking is medium. Any risk rating between 1 to 4 is low. Any risk rating between 5 and 12 is medium, and a risk rating between 15 and 25 is high. NB. Some risk assessment use 5 ratings and are more precise than some that use only 4 ratings. Likelihood or probability level. Rate of 5 means frequent, more than 75%, very likely to occur or already happened. Rate 4 means probable, ranging between 51% and 75%, more than likely to occur. Rate 3 means seldom. It has 50% chance to occur or not to occur. Rate 2 means unlikely, ranging between 10% and 49%, less likely to occur than to not occur. Rate 1 means improbable, have a chance up to 10% to occur. It is improbable. Consequences: severity, impact to human beings. Rate 1 means a single person only injured but no LTI. Lost time injury equals medical leave. Rate 2 means a single person only injured but 1 to 2 LTI. Lost time injury equals medical leave with light reversible health effect. Rate 3 means a single person only injured with 3 LTI. Lost time injury equals medical leave with moderate reversible health effect. Rate 4, related to 1 fatality or 1 person has irreversible health effect. Rate 5, related to multiple fatality or many hospitalized with irreversible health effect. Consequences: severity, impact to environment. Rate 1 is related to a minor environmental impact and easy to repair. Rate 2 is related to a moderate environmental impact within the area of operation. Rate 3 is related to a significant environmental impact outside the area of operation. Rate 4 is related to a major environmental impact outside the area of operation and almost irreversible. Rate 5 is catastrophic to environment and impossible to contain. In risk assessment, we have get a hazard identification. Any control measure related to the basic conditions of the process or equipment that has to be assessed. After hazard identification, we have to determine the basic risk level by multiplying the likelihood with its severity. We have then to set related countermeasures that will enable us to reduce the risk level to an acceptable risk or to a marginal risk by using different methodology. The more efficient is the one called Fine and Kinney that we will find in the following slides. Concerning an example of how to carry out a risk assessment, we have in the table two tasks, one related to excavation and another one related to reparation of roof. By considering the basic conditions in place, we have found the risk level, and after using countermeasures, we have reduced the risk level to an acceptable risk. Get to know that any critical risk or unacceptable risk level is a threat to employees, and the process is to stop and resume after having fixed that risk. Your risk evaluation should consider the importance of the activity to your business, the amount of control you have over the risk, potential losses to your business, any benefits or opportunities presented by the risk. Once you have identified, analyzed, and evaluated your risks, you need to rank them in order of priority. You can then decide which methods you will use to treat unacceptable risks. How do you control the risk? Use hierarchy of control. Controlling exposures to hazards in the workplace is vital to protecting workers. The hierarchy of controls is a way of determining which actions will best control exposures. The hierarchy of controls has 5 levels of actions to reduce or remove hazards. The preferred order of action based on general effectiveness is elimination, substitution, engineering controls, administrative controls, personal protective equipment, PPE. Using this hierarchy can lower worker exposures and reduce risk of illness or injury. In the picture, we have hierarchy of control of risks. Is less efficient than the administrative controls, and the administrative controls are also less efficient than engineering controls. These also are less efficient than substitution, and substitution is less efficient than elimination of the risk. Elimination. Elimination removes the hazard at the source. This could include changing the work process, for instance, to stop using a toxic chemical, heavy object, or sharp tool. It is the preferred solution to protect workers because no exposure can occur. Substitution. Substitution is using a safer alternative to the source of the hazard. An example is using plant-based printing inks as a substitute for solvent-based inks. When considering a substitute, it's important to compare the potential new risks of the substitute to the original risks. This review should consider how the substitute will combine with other agents in the workplace. Effective substitutes reduce the potential for harmful effects and do not create new risks. Example of forklift that can replace manual handling. Engineering controls. Controls reduce or prevent hazards from coming into contact with workers. Controls can include modifying equipment or the workspace, using protective barriers, ventilation, and more. Engineering controls can cost more upfront than administrative controls or PPE. In this picture, a lab fume hood is an example of an engineering control that uses local exhaust ventilation combined with an enclosure to isolate a worker from airborne gases or particulates. Administrative controls. Administrative controls establish work practices that reduce the duration, frequency, or intensity of exposure to hazards. This may include work process training, job rotation, ensuring adequate rest breaks, limiting access to hazardous areas or machinery, adjusting line speeds, hazard communication, safe work procedures permits, workplace good housekeeping, personal hygiene practices. PPE. PPE is equipment worn to minimize exposure to. Examples of PPE include gloves, safety glasses, hearing protection, hard hats, and respirators. When employees use PPE, employers should implement a PPE program. While elements of the PPE program depend on the work process and the identified PPE, the program should address workplace hazards assessment, PPE selection and use, inspection and replacement of damaged or worn-out PPE, employee training, program monitoring for continued effectiveness, Employers should not rely on PPE alone to control hazards when other effective control options are available. PPE can be effective, but only when workers use it correctly and consistently. PPE might seem to be less expensive than other controls, but can be costly over time. This is especially true when used for multiple workers on a daily basis. How do you control the risk? Acceptable level. Eliminate the hazard is always the preferred solution. So why do not limit our choice to elimination? Risks must be reduced so far as it is reasonably practicable. All the risks has to be assessed and reduced to an acceptable level, using the best solution, also from resources, cost, time, effort, point of view. Calculate the risk level. For each risk estimate frequency, probability, and severity. 1. Probability index. How high is the probability for an operator to have an accident because of a specific hazard during a specific operation? The index is related to a possible incident. 4. It is an event that happens quite frequently. 3. It is an event that happens sometimes. 2. It is an event that we know it's happened at least once in the past. 1. We know it's never happened in the past, but we cannot exclude it can in the future. It is not possible, or it is so unlikely I would hardly believe it can happen. 2. Frequency index. How frequently an operator is exposed to a specific hazard during a specific operation. The value is related to the activity performed by the operator. 5. Activity performed several times per shift. 4. Activity performed 1-3 times per day. 3. Activity performed 1-3 times per week. 2. Activity performed 1-3 times per month. 1. Activity performed 1-3 times per year. 3. Severity index. In the case the incident happens, what are the effects? The index is related to the worst possible effect to the involved operator. 20. Death. Very severe permanent effects as blindness, major amputation, paralysis. 15. Less severe permanent effects as finger amputation, burn, multiple fractures. 10. Minor or serious but not permanent effects as broken bones, severe cuts. 5. Minor effects as small cuts, minor burns, bruises. Negligible effects or no injury at all. The assessment has to be done for each of hazard activity. 4. Probability and severity. Team shall evaluate the following components: frequency, probability, severity. Note: this material refers to Fine and Kinney methodology for risk evaluation, as this is the mandatory method based on the risk assessment. Existing hazard controls provide risk reduction as they reduce the probability and/or severity of an injury. Here below a guideline for reduction factors. The lowest the factor, the highest the reduction. Reduction factors for probability. Procedures 0.8. Training 0.7. Authorizations 0.6. Audits, surveillance 0.5. Safety devices design 0.4 to 0.1. Reduction factors for severity. Personal protective equipment 0.7. Collective protective equipment 0.7. Safety devices design 0.4 to 0.1. Calculate the overall risk level. The risk level is calculated as risk level equals frequency index times probability index times probability reduction times severity index times severity reduction. Phi stands for frequency index. PI stands for probability index. PR stands for probability reduction. C stands for severity index. SR stands for severity reduction. The risks are prioritized depending on the calculated risk level, using Fine and Kinney methodology. Risk level above or equal to 200 is unacceptable. The activity has to be stopped immediately and not restarted unless effective countermeasures have been implemented. Risk level above or equal to 120 is very high. Countermeasures do be implemented as soon as possible. Consider the possibility to stop the activity. Risk level above or equal to 75 significant. Countermeasures to be planned as soon as possible. Risk level above or equal to 35 is marginal. Countermeasures do be planned, but with lower priority. Risk level above 35 is acceptable. Situation to be kept as it is. Risk level equals to 0.1. No risk at all. If you enjoyed this video, don't forget to press the like button, share and subscribe to our channel, and ring the bell to be notified for the new videos available. To the next video.